Alright, so today I'm going to show you how to use the Minitab Express software to calculate Poisson distribution probabilities. So what I've done is I've chosen this question out of our textbook, which is number 79 in Chapter 6, dealing with the number of car accidents that occur on a stretch of a highway. So the question says, suppose the average number of car accidents on the highway in 1 week is Poisson with mean equal to 2. So remember, the Poisson distribution, that what they'll always give you is a mean number of occurrences over a specified time interval. And we use the Greek letter lambda, which is here, to represent that average. So it says the mean is 2 per week. So the value of lambda here equals 2 per week. Question A wants to know, what is the probability of no car accident happening in 1 week? All right, now this week may be this week or next week, any 1 week. So on any given week, we expect there to be 2 accidents. However, obviously in any particular week, maybe 2 will happen. Actually, the number of accidents that happen next week is a random variable because next week hasn't occurred yet. So we don't really truly know, although the insurance company would expect there to be 2. The reality is we don't know. It could be 0, it could be 1, it could be 4. Who knows? But this particular question wants to know, what's the probability of no car accident happening? Or in other words, what's the probability of 0? So the probability that x takes on the value of 0. All right, well, typically, if we were going to do this by hand using the Poisson formula, we'd have to use the formula e to the negative lambda, lambda to the k power, divided by k factorial, where k is 0 and lambda is 2. So you would substitute those values into the formula and work it out with a hand calculator. However, we could make use of Minitab Express's probability menu to crunch that probability for us. So remember, the probability menu, we've made use of this before. I created a video of the binomial distribution earlier. So you pull up this menu, and there's these 4 features here. The first one creates a picture, graphs. The second one is a cumulative function, where it finds a probability of an at most scenario. That's usually a chunk of probabilities in a table. The inverse cumulative distribution, that's something a little bit different. It works backwards in reverse. We'll be talking about that when we get to the normal distribution. But the one we're looking for is right here, probability density function. This works out one specific value in a table for a distribution. So you have to, in your mind, think about all the possibilities for this Poisson scenario. In other words, we're looking for the probability of no car accident, but maybe there's 1 car accident next week, or 2 car accidents, or 4. We don't know that answer. So you have to create a table, and we could figure out all those probabilities. And remember, if we did find all those probabilities, the sum of all of them would be the number 1. But we choose this option here, probability density function. Remember, you use that when you have one particular value, like x is 0. When you have a chunk of values, we use the cumulative scenario. So it wants to know, all right, what are you giving me? What's the form of input? A single value. Yep, that's what I'm giving you. I want the value of 0, the probability of no accidents. Distribution. All right, well, normal is the default, so we have to go in here and change that. Remember the binomial, we did that earlier. Poisson's another choice here. I really wish some of the other choices were geometric and negative binomial, but unfortunately the Express version of Minitab does not cover that. The full version of Minitab does, and we have that at the college, so you'll be using that when you come to your face-to-face exams. You'll be able to use that if you choose. The only problem with it only runs on Windows. It doesn't run on a Mac. I'm working on a Mac right now, so that's why we're using Minitab Express, so we could all use it across platforms. So I'm going to select Poisson here, and of course now it says, okay, what's the mean? Well, the mean is 2. So what's this going to give me? It's going to give me the probability of no occurrences, given that we're expecting there to be 2 occurrences. Now the output is, where it's going to give you the result. So you could choose to put the result here, this is the session window or the output window, or you could also tell it to put the answers down here. So display a table of probability density values, yeah, that's what I want. So I'm going to choose that first option and say OK. All right, so here we go. Input, distribution, Poisson. The mean is 2. The input value is 0. So it's just rehashing what you gave it and what you asked it. And here it is, the probability density. This means PDF, probability density function. So when x is 0, the probability that x takes on that value of 0, here it is, 0.1353. That's about 13.5%. All right, so the probability of there being no occurrences this week is 0.1353, approximately. Typically, we round these answers to 4 decimal places. All right, let's look at letter B. Letter B. What is the probability of 2 car accidents in 3 weeks? All right, 2 car accidents in 3 weeks. The first thing you should notice is that they are changing the value of the time interval. In the beginning, they were talking about lambda, the mean. It was described to you in 1 week. Part A talked about car accidents in 1 week. Part B, however, talks about car accidents over a 3-week period. All right, so they're changing the time interval. If they change the time interval, then the number of car accidents that you would expect to see on average over those 3 weeks has to change. So something like this is kind of common sense. You could work this out in your head. If you're expecting 2 accidents per week, so over a 3-week time interval, you would expect to see about 6 accidents over 3 weeks. So in other words, the value of lambda is going to change. So lambda, my goodness, with this Microsoft Word and its automatic numbering drives me crazy. So the value of lambda here is going to be 6 accidents over a 3-week period. So notice you change the time interval, you're going to change the value of lambda as well. Alright, so we're going to make use of that. So now what does it want to know? What is the probability of 2 car accidents? Alright, well, the probability of 2 car accidents, that's going to say Px equals 2. Alright, so the probability, x takes on a value of 2. Now, make sure you realize that it's asking you the probability x is 2, given the fact that now lambda is 6. Alright, so we'll calculate that probability, again, using either the formula for the Poisson or the probability calculator or Minitab. So let's make use of the Minitab probability calculator. So again, I'm going to pick probability density function. A single value, yep. What's the value? The value in this case is 2. I want to know what's the probability of 2 accidents happening in a Poisson distribution with a mean number of occurrences of 6. So by the way, so think of it this way. Given the fact that on average 6 accidents should happen in 3 weeks, what's the probability that this week, it's a little light? There's only 2. So you say, okay. And here we go. The input, what do we give it? Poisson distribution, the mean is 6. The input value is 2. When x is 2, the probability of 2, 0.0446. Alright, so over here, 0.0446. Obviously, once you get fast with this Poisson calculator in Minitab, you really work these things fast. It's a lot faster than using the actual formula. The formula, obviously takes a little bit of time. Alright, part C. Alright, so part C, looks like we're back to 1 week again, it says. Yeah, it says, what is the probability of more than 1 car accident in 1 week? Alright, so we're back to a 1 week time period. So this time, we're back to the scenario where lambda is 2 per week. You see, that, honestly, that's the most important thing that you have to worry about with this Poisson distribution. You get from question to question, and if you find you're making a mistake, and you feel like you're doing the right thing, and you keep getting a wrong answer in My Math Lab, the issue usually is you didn't see the change in the time interval, and you're using the wrong value for lambda. I can almost guarantee that would be your issue. All right, so let's talk about the probability statement right now. So this says the probability that x is less than or equal to, not less than, I'm sorry, more than 1. All right, so think about that. Greater than 1. Oops, for some reason my greater than key is not working there. Greater than 1. All right, so think about what that means. More than 1 accident means you might have 2 accidents, or you might have 3 accidents, or 4 accidents, or 5, or dot, dot, dot. All right, that could be obviously impossible to work. I mean, I think that you can see that that's very difficult. So how you should think of it is this. Let's put a little table in here so our minds can think of it a little bit better. I'll just put a few values in here. I'm not going to go crazy. So think about the possibilities for these random variables' values. So here's x, and here is the probability of x occurring. It is possible that there will be no accidents this week. All right, we already worked that. That answer is right here, 0.1353. So we know that answer already. There may be one accident this week, or there may be two, or three, or four, 5, 6. All right, so I'm running out of room here. I only created a table that has 6 entries in it. In theory, this table keeps going and going and going. So, we didn't work all these probabilities, obviously. We only worked the first one. Don't get confused here. The probability of there being 2 accidents, that's not this 2 right here. This 2 is when the value for lambda is 2 per week. The probability of x being 2 right here was when the value of lambda was 6 per week, 6 per 3 weeks. That's not the same thing. So we can't take this 0.0446 and put it in this spot right here. All right, so now think about it. I want to know the probability that there are more than one accident. So I would need to know, here's a chunk, 2, 3, 4, 5, 6, and keep going, 7, 8, 9, 10, ... to infinity. Now, eventually what starts to happen, I mean, think about it. If you're expecting 2 accidents this week, what's the probability of there being 100 accidents? Clearly, that's a very odd scenario, and its probability is very, very, very low. We would just assume it's 0. So eventually what happens is as these values start to increase, whatever the mean is, which in this case is 2, the highest probability values would occur near the 2. So like 1, 2, 3, 4, these values here, those would be the high probabilities. And then as you start getting away from that average, which is 2, 6, 7, 8, by the time you get to like 15, the probabilities are getting probably really small. We could calculate them all if we wanted to. It would be a very easy thing to do. But at the end of the day, we don't need to know them all. We really want to know what's the answer from 2 to infinity. If I take 2, 3, 4, 5, 6, 7, ... and add them all up. So if I somehow find all these probabilities and keep going down, what would the answer be? Well, that would take us too long. We don't need to do all that work. Matter of fact, if I knew, I know 0's probability. If I knew this probability right here for 1, if I had this one other probability, the sum of these 2 would give us 0 or 1. Well, think about it. If you want from 2 to forever, 2 to infinity, and you should know by now that all the values in the probability column add to the number 1, because that's the one of the main properties of a discrete probability distribution. So think about taking 1 and subtracting off 0 and 1's probability. That would give you the answer to the question. So we don't calculate the probability x is bigger than 1 directly. Instead, we work it like this. 1 subtract the probability that x is, and I want to insert less than or equal to symbol in here. Oh, there we go, it did. Okay. Less than or equal to 1. All right, so think about what that says. Got my equal sign here. Let me put that in there. The probability, the number of occurrences, number of accidents is more than 1. More than 1 meaning what? 2 and more. Remember, for accidents, you can't get into a piece of an accident. Either you crash or you don't, right? So saying more than 1 is the same thing as saying 2 or more. All right, so instead of working 2 to infinity, instead we're going to take everything, which is 1, and subtract off 1 in backwards. So how you should look at this statement right here, if you want to be 2 in forwards, take everything and subtract off 1 in backwards. All right, so now the question is, how do I find out the probability of being 1 or backwards? All right, well, you need these 2 probabilities right here. We have one of them. So if you want, you can do this a couple of different ways. You could first work this, if you want, by just finding the probability for 1. So we could do that. And then after you find the probability for 1, just add them together, the probability of 0 and the probability of 1. So if you want, you can just go to probability here and go to probability density function, single value. Yeah, the value is 1. It's Poisson with mean 2. And get this value right here and say, okay. It crunches it. There it is, 0.2707 if you round it. 0.2707. Find the sum of those two probabilities. That'll get you the probability of being less than or equal to 1. Subtract that result from the number 1, and that will be the answer to the question. All right, so you could do it that way. It's a fine way to do it. So you could think of it like this. So the, this probability being greater than 1 is going to be 1 subtract 0.1353 plus 0.2707. Alright, so let's use a hand calculator for that. 1 subtract 0.1353. Alright, so I'm getting approximately 0.594. Alright, so there you have it. Not too bad. There's a better way. And you know, remember, if you want to work a chunk of probabilities, like if you want to work the scenario of 1 and backward, which is the sum of these two probabilities. Well, over here in Minitab, that's what this cumulative distribution function does. Remember, the word cumulative means from the beginning. So what you do is if you select cumulative probability and say, okay, I'm going to give you a single value. What am I going to give it? Well, I'm going to give the value 1. And it's going to be Poisson with mean 2. And you're saying, wait a second, didn't we just do that a minute ago? We just worked this, and it gave me this one probability right here, this 2707 number. Yeah, but I'm selecting cumulative probability. So when you have cumulative probability selected here, and you give it a value of 1, it's not just going to work the probability of 1. It's going to work that probability, and simultaneously, it's going to work the probability of none. So it's going to work 1 and backwards, and simultaneously add these two. So it's going to give me the sum of those two, which you can do it in your head. I mean, it's about 0.4, right? Give or take, right? Yeah, about. So I say, okay. So when I do this, I'm expecting to see around 0.4. There you go, 0.4060. So, and look at the output says. First of all, it's saying it's a cumulative probability. It means 2. I'm giving it a value of 1. So there's the 1 right there. But look at the statement right here. It says the probability x is less than or equal to x. So not only does it work 1, it works out 1 and everything that comes before it. 0.4060. Substitute that in this place right here. That's the sum, that 4060. That's the sum of these two things right here. So you can give that a check. And obviously this would speed things up for you. So you would just do this as 1 subtract 0.4060. And of course, that would give you your 0.0594. The cumulative function's a lot easier to work. All right, so this is the probability of more than one car accident. That was part C. I think it's maybe you should see it like, you know, what if I was to do this, the cumulative distribution function, and say I give it a 6, and say Poisson with a mean of 2. Now, of course, the question over here doesn't ask us to do that, but I think you should see this. Like, in other words, over here, you know, I created this table. What if I wanted to find the sum of the probabilities from 6 and backwards? Now, that would take some time. If you had to work all those by hand, clearly you say cumulative probability. I'm going to give you a 6 with a mean of 2. So when I give an input of 6, it's going to work 6, but it's also going to work 5, 4, 3, 2, 1, and none. And then simultaneously add them all up for you. And as you can see, look what the probability is. It's almost 100%. This is 0.9955 approximately. This is basically letting you know that the chances of there being 7 accidents or 8 accidents or 9 accidents, not so good. And of course you can check that too. Like, you know, remember before I said, you know, what's the chances of there being 15 accidents? Like, you know, something like that. You go, the chances of being 15. I mean, think about that. You're expecting 2 accidents this week. What's the chances of there being 15 accidents? Minitab just says, it's 0. Is it really 0? No, it's probably 0.0000001. You know, some ridiculous number like that. So the reality is, once you get far away from the average value, remember the average value was 2 accidents in a week, the probabilities get very, very small. And remember, the sum of all these probabilities in the table is the number 1. All right, so like always, if you have any questions, shoot me an email. I'll be happy to answer them for you. I'll be posting a video on how to do some negative binomial probabilities as well, so you should look for that. Obviously, we won't be able to do it in Minitab, but I'll show you how to work those